right, here's our study guide for Unit 2B, which is on triangles. So on the first one, we are simply using the idea that all the angles of a triangle equal 180. So that should be no problem. When I take 180 minus 48 and 87, I would get 45 degrees. What's left over when I take away 48 and 87. All right. For the next one, the same idea is that the sum of the angles of a triangle would be 180. So that's the equation I'm going to set up. I'm going to sum them, add them up. 3x plus 6x plus 11x equals 180. That's my equation. Then I combine like terms, and I get 20x equals 180. Then I solve for x, divide by 20, and I get x equals 9. All right, and then here's where you got to be careful because it says determine the measure of angle E. All right, so I need this one, which is 6x. So the measure of angle E is 6 times 9, which is 54 degrees. Okay, so don't miss your directions and don't stop too early. Number 3, we're going to solve for x. So again, the same idea, all the angles of a triangle equal 180. So I'm going to take 3x, and let me switch over to drawing, get a little smaller pen. Okay, let's see if this works. So I've got 3x minus 17 plus 2x minus 5 plus 42 equals 180. So I'm going to take the 180 away and subtract it to both sides. Well, actually, no, let's not do that. We'll combine like terms on the left side first. So that's going to leave me with 5x when I combine x's. And when I add those numbers up, I'm going to get 20 equals 180. Keep solving. 5x equals 160. And then divide by 5 to get x equals 32. And that's all we had to do was solve for x, so we're good there. All right, number 4. All right, so using what we know about triangles, if I have this first one, we've got 180 minus 28 and minus 39. So however you want to do that in your calculator, I'm going to subtract them both, and I'm going to get x equals 113. I can use linear pair to get this next one. So that's going to be 180 minus 113 would get me a 67 degrees. And then for z, I've got another 180 minus 64 and 67, and that gives me 49 degrees. So just using your triangle sum to work your way around to get those. All right, up to number 5. Now we've got an exterior angle. So we know that this angle equals the sum of those angles, the non-adjacent. So this one, we know this one would equal 180 because that's a linear pair. So this kind of should make sense, this idea. So let me turn pages here. All right. So the equation would simply be exactly what we're saying. 113 equals the sum of the opposite angles. Solve that for x. And x is equal to 60. And we're done. It just wants you to solve for x. All right. Determine angle B. So we're looking for the value of 3x. So the same setup, 124 is the exterior angle. It equals the sum of the two across from it that are the non-adjacent angles. Set that up, start solving for x. X equals 124 divided by 4 is 31. And we are not done because we need the value of angle B. So the measure of angle B equals 3 times x, which is 93 degrees. All right, 7, the same setup. We have a remote exterior angle. 6x minus 7 is equal to the sum of these angles, 103 minus x plus 2x. So we got a lot of variables all over the place. So I'm going to combine like terms over here. 103 plus x, 2x minus x, and 6x minus 7. Okay. I'm going to move this x to the other side. And now I have 5x minus 7 equals 103. And then I will add 7 to both sides. 5x equals 110. And then x equals 22. All right, and that's all we had to do there was solve for x. All right, let's mark down everything this is telling us. So SRT is congruent to STR. All right, so base angles are congruent. That means I also have congruent sides in case I need them. SRT is 68 degrees. Okay, STU is 4x. Solve for x. All right, a couple ways you could do this. One, probably the easiest way is to notice that these are congruent, so therefore this is 68, and then that makes up a linear pair. 4x plus 68 should equal 180, and then from there I will solve for x minus 68 both sides equals 180 minus 68 is 112. Divide by 4. X equals 28. And again, we are just solving for x. The other way you could have done it is go ahead and solve for this angle S and then had 4x equal the sum of the other. Treat it like it's a remote exterior angle. So that would have been 4x equals 68 plus 44. If you've calculated that, that would be 44 degrees. So either one would work. It's just a matter of which you notice and which one you do. So x equals 28. All right, number 9. The key here, equilateral triangle. So what is that telling us? It tells us we have 3 congruent sides. May or may not need that, but we definitely need to know that we have 3 congruent angles. If it's equilateral, all angles will be 60 degrees. That's just the way they have to be. So I can say 6x equals 60. So therefore, x equals 10. And I can say that 9y minus 3 equals 60. So that means that 9y equals 63. Divide by 9. Y equals 7. All right, and all we had to do there was solve for x and y. So we are done with that one. Next one, they tell us AB and BC are congruent. Angle B is 32. This one was actually on the sheet we did yesterday. We worked this exact same problem, but we'll do it again here. All right, congruent sides, congruent base angles. it's isosceles. So 180 minus the 32 gives us 148. That means I have 148 degrees to split between these two angles. Okay, so I'm going to split it in half and give 74 degrees to this side, 74 to this side, and we needed to solve for angle A. All right, what's important here, these base angles are congruent because they're both 61 degrees. That means the sides are congruent. That means we can say that x plus 3 equals 5x minus 21. And then solve for x. So I would choose to subtract x from both sides. 3 equals 4x minus 21. Add 21 to both sides. So 4x equals 24. Divide by 4. And x equals 6. And we're not done because it says find the length of the two labeled sides. So we need to go back and substitute. 6 plus 3 is 9. And 5 times 6 is 30 minus 21, which is also 30 minus 21 is also 9. And they're congruent, so we would want to see that equal to. Alrighty, next, solve for x and y. This is an equilateral triangle. Alright, so this one is going to have 3 steps to it. First, solve for x by setting them equal. They are congruent, so we can set them equal. Alright, solve for x. And 5x minus 7 equals 8. Add 7, add 7. 5x equals 15. Divide by 5. X equals 3. All right, now we don't have any way to solve for y because we don't know anything else. But what we can do is figure out this length. Okay, so 3 plus 8 is 11. And that tells me if this side is 11, then this one's 11, and this one's 11. So if I know the side length, now I can set up an equation. 3y minus 7 equals 11. 3y equals 18. And divide by 3. Y equals 6. So here and here, solve for x and y. Okay. And we're on the home stretch, the last page. We have a mid-segment. We can say that 5x minus 1 equals half of 58. Half of 58 is 29. So that would be the equation to solve for x. We're going to actually solve for x, so add 1 to both sides. 5x equals 30. Divide by 5. X equals 6. So x equals 6. And then it says AB is blank to CD. AB and CD. AB is a mid-segment, and they are always parallel to their matching side. Alrighty. For x and y, if the lines inside the triangle are mid-segments, so they're saying they're mid-segments, so that means x matches up to 28. X is half of 28, so x is 14. And then 15 is, sorry, I got buttons happening over here. Y plus 6 is half of 15. Well, half of 15 is 7.5. And solve for y. Y equals 1.5. And you're done. Can three segments that measure 100, 115, 220 make a triangle? So we said that the two smallest the sum of the two smallest must be greater than the largest side. All right, so we got 100 and 115 equals 215. Is that greater than 220? No. This cannot make a triangle. 215 is not greater than 220. It needs to be greater than the third side. All right, the range of possible values. So we've got 7.5 and 15.5. What could the third side be? So easy way, add up the two other sides, and that's going to come to 23. That's the high end. And subtract 15.5 minus 7.5, and that's going to equal 8. So the range of possible values is less than 23, but greater than 8. And it looks like that is done. So triangles everywhere. Okay. All right, y'all have a great day, and we'll talk to you soon. Bye-bye.